Hi students, today we'll be discussing the concept of exothermic reactions. Now, an exothermic reaction is a reaction in which a material or a source releases energy out into the environment or into the system. The most common reaction that you probably are familiar with is any kind of combustion reaction. In a combustion reaction, you are lighting something on fire, and that source of material, a hydrocarbon-rich material, is breaking down and combining with the oxygen in the environment and is producing certain byproducts, particularly carbon dioxide, water, and light and heat. So this has been an important reaction for human society, being able to light things on fire to keep us warm and to keep us able to see in the evening is a really important development in human technology. So let's just take a quick and simple look at this process. So right now we're engaged in a combustion reaction. The paper is made of hydrocarbon sugars, basically, and as we can see, there is heat. Well, you can't see it, but I can see it. There is, feel it, I should say. There is heat, and there is light that is emanating from this material. So our fuel source, in this case, something that is rich in hydrocarbons, is being broken down into carbon dioxide, which we can see coming off, and water. And the byproduct is the heat and the light. Combustion is an important reaction that we have to understand. It is similar to what is actually happening inside of us when we are eating. Respiration is a kind of controlled combustion. You don't, when you think about when you eat, let's say, a bag of popcorn, you're chewing it, breaking it down, and inside of your body what is happening is the sugars are being broken down at the cellular level into their fundamental components, which the end result will be carbon dioxide, which we exhale out, and water, and then the heat energy that we get, which will essentially enable us to do work beyond. So when we think about exothermic reactions, really the important thing is thinking about this idea that there's material that is releasing energy out into the environment. So it's from inside to out. Fire would be an example of an exothermic reaction or combustion. Digestion, or that whole process of respiration where we breathe in to bring oxygen into our body, which enables us to have a controlled combustion of the food that we're eating, and then we exhale out the waste, the carbon dioxide waste. There are other examples of exothermic reactions. I mean, any reaction that results in the material rearranging and releasing energy, usually in the form of light or heat, into the environment is an example of an exothermic reaction. So let's take a look at another exothermic reaction that can happen in a lab. All right, so we are looking at a beaker filled with 75 milliliters of water, and my thermometer reads the temperature at between 24 and 25 degrees Celsius. If I had a digital thermometer, I could be more precise than that, but that's what I've got. And we have here calcium chloride, CaCl2, and I weighed out 10 grams of calcium chloride. So I'm going to add this to our water, and let's see how this affects the temperature of the water. So you can see it is increased from 24. It is currently shooting past 30. I can feel the Pyrex. It is a little warmer to the touch. If I had, let's say, if I had this in a plastic bag, it might be easier to observe. We can see some fizzing happening. This is not completely dissolved. Let's see if we can increase the reaction rate by further dissolving this. If I used a magnetic stir, it would probably go even faster. Yeah, the temperature is continuing to increase. I can feel the heat. It is past, or it is close to 35. And the bottom of the beaker is much warmer. Wondering how long it will take for this to peak its temperature. This is an exothermic reaction. As the calcium chloride is interacting with water, the calcium and the chlorine are dissociating, and it is producing hydrochloric acid, and heat is generating in this reaction. It looks like it's peaking at about 35. Now, I'm sure I could help the temperature increase if I had this in a plastic bag or something where the heat would stay encased. But this is, I think, a great example, a simple and a safe example of an exothermic reaction. So to sum up, exothermic reactions are reactions where energy is released from a source, from material, and is released into the environment. So the most common reactions that we will notice in day-to-day life that are exothermic reactions are combustion, respiration. Those are examples of exothermic reactions. Ice forming is an example of an exothermic reaction where the heat from the water is leaving. So when we say that the ice is forming, we are essentially saying that the heat is escaping from the water. Those would be common examples of exothermic reactions. In a laboratory, one of the more common exothermic reactions that we will see will be any oxidation reactions whereby the element or the molecule is losing electrons. So oxidation reactions are generally exothermic reactions. One common one that we'll see in a lab would be a neutralization reaction. A neutralization reaction would be an example of a base combining with an acid, and then those molecules will rearrange themselves to produce a salt and water as a byproduct, and also releasing heat out into the environment. So those are the three in class that you would anticipate seeing as exothermic reactions. All right, this has been a lot of fun. I'm looking forward to talking about endothermic reactions next. See you later.